So the next thing I want to talk about is measuring variability. And we're going to talk about more measures of variability other than quartiles, which are standard deviation, that's like the number one in statistics, and range. So here we have a graph of the average phone use per day in minutes from 3 different samples. So I took 3 samples of our population. I got them in a nice random way. And as we can see, our sample A has a greater range than our sample B, and then our sample C. So the range of a set of data values is the difference between its highest and lowest data values. So the difference between the max and the min. And the min can tell us quite a bit about variation or how our data is spread, right? Because sample A has a wider range, we could say there's more variation in the data values than, say, sample C, which is more concentrated, has a smaller range, and therefore has less variation. Well, what is variation? Variation describes how widely data are spread about the center of a data set, right? So sample A has greater variation than sample B, which has greater variation than sample C. And variation isn't necessarily bad, but we do need to be able to describe the variation, right? So let's look at another example. So let's consider the following 2 sets of quiz scores for 9 students. So which set has the greater range? And which set will we say has the greater variation? So the greater range, well, let's calculate the range for quiz 1. It's 10 minus 1, which is 9. And the greater range for quiz 2 is 10 minus 2, because that's our max, that's our min. How nice that that data was already sorted for us. So we've got a range of 9 and a range of 8. So which set has the greater range? Well, that's going to be quiz 1, right? But which set has the greater variation? Which set has the greater spread? Well, quiz 1, all of the values are 10 except for this guy, right? So that's kind of very little variation. That one, probably an outlier if we're going to be honest, right? But quiz 2 has a greater spread. So quiz 2, you can't really see that very well. I said quiz 2. Quiz 2 has the greater variation. Well, what number do we use to describe variation? So range is great. Our interquartile range, also helpful. But in statistics, the value we use the most is standard deviation. Standard deviation is what statisticians use to describe variation with a single number. And it's a measure of how spread data is around the mean. Note I said mean and not median. So how do I measure this variability? How do I calculate the standard deviation? I want to tell you right away that you can use R or Excel or a scientific calculator to calculate the standard deviation, but I'm going to walk you through how to do it by hand. You will not be required to do it by hand. You will be able to use technology. Okay, so now that I've said all that, let me show you the equation. So, like I said, we measure variability with the standard deviation. So variance, S squared, of a set of objects is an average of the squares of the deviations of the observations from their mean. I'm going to break this down more slowly, I promise. So let me just get there. So I describe variation as the difference in my data values. So I take x minus the mean squared plus our second data value minus the mean squared, and so on and so forth, all divided by n minus 1, where n is my sample size. I spelled sample wrong. Sample size. So I could write this in summation notation. Remember, that's our capital sigma. This means sum of 1 over n minus 1 of all my different data values, every single one for my sample size n, minus the true mean squared. So that's our variance. Our variance is S squared. The standard deviation, S, is the square root of our variance. So our standard deviation, S, is our square root of our variance. So let me walk you through the standard deviation formula specifically. This is the form I prefer. So here we have S, which is our standard deviation. We're taking the square root of our variance, which is the sum of our sample values minus our mean squared over n minus 1. So the symbol S is our conventional symbol for standard deviation, where x bar, we already know that to be the mean. X is each specific data value in our data set. Probably important to include that in our data set. And n is our total number of data values, so otherwise known as our sample size. So let me walk us through the steps to finding the standard deviation. Okay, so here's what we're doing first. First thing we need to do is find the mean of our data set. We need that x bar. Then what we do is we find the deviations from our mean. So we take each data value minus the mean. We want to know like how far each piece of data is from the mean. Then we take the squares of all the standard deviations from the mean, because if you think of a data set, you're going to have some values below the mean, which would mean their deviations are negative. So if we square them, it makes everything positive. Then what we do is we take the sum. We add them all together, and we divide this sum by the total number of data values, n, which is our sample size, minus 1. And then our standard deviation is the square root of this. So it's the sum of all the deviations, typo, deviations from the mean over our total number of data values minus 1. So let's work through an example step by step. Again, you do get to use technology, but I want you to see how this is done. Okay, so the first thing we're going to do is let's calculate the standard deviation for the sample of scores on a 15-point quiz. So it's a very small data set, right? My n is 4. So I go ahead and calculate the mean. So I'm taking all my data values, 11 plus 9 plus 8 plus 15, all divided by 4 equals 10.75. So that's my x bar, that's my mean. Then I need to find every single value's deviation from the mean, right? So 11 minus our mean is 0.25. 9 minus our mean is negative 1.75. We've got 8 minus our mean is 2.75. And 15 minus our mean is 4.5. Now I have to take the squares of all those because some of them are negative and we want those values to become positive. So I square all of those data values. So now that we've taken the squares of all of our deviations, we have to take their sum, which means we add them all up and we get 28.75. So that's the sum of all the squares of our data values deviation from the mean. Next, we divide that by n minus 1. Remember, n is our total number of data values. So I get 9.583333. That's way too many decimals. Like, don't feel like you got to keep track of that many. And then we go ahead and take the square root of that because what we just found, this was s squared, which is what we call the variance. So when I take the square root of this, I get 3.096. So our standard deviation is 3.096. That means that on average, our data values are 3.09 standard deviations from the mean. And you could round this to 3.1. Like, I'm okay with that. So let's talk about some properties of our standard deviation. So first off, it's important to know that n minus 1 is called the degrees of freedom. This will come up, that's typically denoted df. This will come up later when we're working in students' t-tests. Oh my gosh, that's like at the end of the class, so no pressure to remember that. S measures the variability about the mean, should only be used when mean is chosen as the measure of center. Like if we don't think mean's the best measure of center, for example, typically with income, we wouldn't use mean because we've got a ton of outliers, right? If there's a lot of outliers, we prefer to use the median instead of the mean, then we shouldn't look at the standard deviation. S is always 0 or greater than 0, right? So our standard deviation is 0 or positive, right? We can never have a negative standard deviation. And it's important to note that our standard deviation is only 0 when there's no variability. So let's say everybody took a quiz and got 100%. Good for you guys, but there's no variation, i.e. all observations have the same value. Next, as the observations become more variable at their mean, our S gets larger, right? Like if I've got do I want to draw a picture? If I've got a bigger spread of data, like if my data is kind of spread out like this, that's going to have a larger variation than if I had like a smaller spread of data, like a smaller range, right? That's going to have a smaller standard deviation. So as our range gets bigger, our standard deviation gets bigger as well. Clean up my mess. Okay, next, S has the same units of measurements as the original observations. So if our data values are in kilograms and our mean's in kilograms, so is the standard deviation. If our mean was in inches, the standard deviation would also be in inches, right? They have the same units, right? Same units, key takeaway. Remember, if I'm talking about the variance though, then it's our unit squared. And like the mean, S is not resistant, right, to outliers, right? By resistant, I mean resistant to outliers. A few outliers could make our standard deviation very large, right? So how do I choose what measures to use? So I need to choose measures of center and variability. I just said we can't use standard deviation when we're using median, but what do I use? So if I'm using mean, it's going to have a standard deviation. If I'm using median, we're going to use our interquartile range, that IQR, which is Q1 minus Q3. That's what I'm going to use. And when I'm choosing a summary, the 5-hour summary is usually better than the mean and standard deviation for describing a skewed distribution. And we typically only want to use the mean and standard deviation for symmetric distributions, like Bell distributions, that are free of outliers. So if you've got outliers or skewed data, either skewed left or skewed right, median and mean and median and interquartile range and the 5-hour summary, those are your best. So let's take a look at a few examples of technology. In this class, we're using R, but I have visuals below from a graphing calculator, right? You can do, it doesn't have to be Texas Instruments. What's with this branding? But any graphing calculator should allow you to do statistical analysis. If you have any questions about that, feel free to send me like, hey, I have this type of calculator, and I'll try and get you the correct documentation or find an instructional video or make one for you. You can also use statistical software. I use Stata. I've used SPSS. These are all just like statistical software. We're using R, right? Like R is what we are using in this class. And you can also use Excel, old school, but totally works. And will help you calculate the standard deviation, because if you have a data set that's size 4, it was totally okay to calculate that standard deviation by hand. But if you've got a huge data set, this is not something you want to do by hand, or should, or even could, okay? So as we move forward in this course, we're talking about how to address statistical problems and how to learn by exploring data. So we need to talk about how to organize a statistical problem. So as we learn more and more about statistics, right, as we go on in this course, we're going to be asked to solve more and more complex problems. So it's important to stay organized. So here's our 4-step process as we go through this course. So first, what we want to do is state what's our practical problem, right? What is the practical question in the context of the real world setting, right? We also need to know what specific statistical operations does this problem call for. Right now, we're really just focusing on measures of center and variation, but we're going to keep building as we go through in this course. Then we need to solve so we can make graphs or carry out calculations, right? By calculations, I mean stating things like measures of center, standard deviation. And then we need to provide a conclusion. And that conclusion typically needs like statistical evidence, which we're going to talk about even further as we move forward in this course. So stay tuned for chapter 3.